In this lesson, we're going to be going over fractions. So I've titled it Getting Comfortable with Fractions. Our purposes today are to understand fractions, to learn to simplify fractions, to learn to add and subtract, as well as multiply and divide fractions, and then I have an application problem at the end involving fractions. So first, when dealing with fractions, it's important that we recall the number line. Okay, so we have our number line, and we have 0, we have 1, 2, 3, and so on. Okay, so what's in between our integers? So our integers are our positive and negative whole numbers. So for instance, what's like right here? Okay, you may think, oh, that's 1/2, which is exactly right, and that's a fraction. So that's where our fractions come into play. If you worked with like a ruler or a measuring tape, you see those little lines marked in between your whole numbers. That's where the fractions are coming into play. So the answer there, what's in between integers, are fractions. So again, like you could be here, and this could be like 1 1/4, or here would be like 2 1/2, okay, and so on and so forth. Okay, so let's continue to talk about fractions. Fractions come in the form of A over B, where this fraction bar here means division. Okay, so A divided by B. What fractions are equal parts to a whole. So let's say we have a fraction of 2/3. This means that my whole, the bottom or the denominator means that my whole has been divided into 3. Pretend those are equal pieces, and I would be talking about 2 of those. So this would be a representation of 2/3. Some common examples of fractions that we see. So 1 penny or a cent is 1/100th of a dollar. So if you have 100 pennies, you make a whole dollar. A quarter money is 1/4 of a dollar, or that's also why it's called a quarter. A quarter in sports is 1/4 of the whole game. So for instance, football is broken up into 4 equal quarters of 15 minutes. The whole 60 minutes has been divided into 4 to give us 15-minute quarters. Okay, and so whole numbers can also be written as fractions. So let's say you have the number 7. This is the same as 7 over 1. So we'll keep going. Example 1 here, I just want to take a moment to visualize fractions. So in your notebook, make as many visual representations as possible of 3 over 4. So one that I tend to go to is a circle. So we've got a whole divided into 4 equal parts, and we're talking about 3 of those. Okay, so the shaded region would be 3/4. You can also talk about, let's say, blocks. So if we talked about 3 of those, this would be 3 of 4. You could also have a rectangle. Pretend those are equal parts. 3 out of 4, and so on. You're probably more creative than I am, so I'm sure you thought of some pretty cool ways to visualize 3 over 4. But there is a visual representation behind our fractions and what we're looking at. Okay, so the first topic that we're going to talk about is simplifying fractions. So when we simplify a fraction, or when the instructions say to simplify a fraction, that means to get it as small as possible. So for instance, we have equivalent fractions. We have 8 over 16 is equal to 1/2. So visually, I'll show you why these are equivalent, equal to one another, and we'll also talk about why we know that 1/2 is the smallest version of 8 over 16. So let's say I have a box, and I divide it into 16 pieces. Okay, and then let's say I'm talking about 8 of those. So this is 8 out of 16. Okay, and let's say I have the same size box. With my drawing, you have to use your imagination a little bit. And I divide it into 2. And okay, hold on. We're going to do the same size box. Pretty close. One's a little bit bigger. Okay, I'm going to do the same size box. And we're going to divide it in half to be 1/2. So as you can see visually as well, if you look at the shaded regions of 8 over 16 and 1/2, they're the same size. So if you take the same whole, divide it into 16 pieces and talk about 8 of those, it's the same as if you take the same whole, divide it into 2 pieces and talk about 1 of those. Okay, the other thing that you may know or recall is that 8 and 16 have common factors. Okay, so the biggest common factor is 8. So if you divide both the numerator and denominator by 8, you would get 1 over 2. Okay, so we know that a fraction is in simplest form when the numerator and the denominator have no more common factors. And by common factors, we mean numbers that they can be divided by. Okay. So example 1, we'll talk about simplifying fractions. So you may see this in a couple different ways. The instructions could say simplify or write the fraction in lowest terms. Okay, so the way to do that is we're going to learn how to do it by hand first. And then at the end of this lesson, I have some calculator buttons that you may find helpful. They may not be the exact same buttons on your calculator, but hopefully they'll give you an idea of what to look for on your calculator, and I can always work with you on that as well. Okay, so 10 over 25. So when you're simplifying fractions, identify the greatest common factor or just a common factor that you see right away. So with 10 and 25, 10 ends in a 0, 25 ends in a 0. So I know they're both divisible by 5. So you divide the top and bottom by 5. 10 divided by 5 is 2. 25 divided by 5 is 5. And our final answer is 2 over 5 because 2 and 5 have no other common factors. Okay. Part B, for 7 over 49, our common factor here is 7. So we divide both the top and the bottom by 7. Okay, now 7 divided by 7 is 1. 49 divided by 7 is 7. So this becomes 1/7. Okay, it's a common mistake to say, okay, 7 divided by 7 doesn't matter, so 49 divided by 7 is 7. 7 is very different than 7 over 49. I'd rather have $7 than 7/49 of a dollar. Okay, so be careful when you're simplifying that way. And then the last one, 256 over 128. These are big numbers, and so what I said at the beginning of this example may come into play where if you're not sure of what the common factor, the greatest common factor is between the two, 256 and 128, start with what you know. Both numbers are even, which means both numbers are divisible by 2. So we're going to divide each by 2. So 256 divided by 2 is 128. 128 divided by 2 is 64. And both are even, so we can keep going. So I'm just going to keep dividing by 2. Okay, so from here you may see what's going on, or you can keep going. Okay, but this would turn out to be a whole number 2. So that's our lesson on simplifying fractions. Next, we're going to talk about adding and subtracting fractions. So in order to add and subtract fractions, you need a common denominator. And then what you do is you add or subtract the numerator and your denominator stays the same. And here's why. Let's say we were talking about that you have 3 oranges and 2 apples. And you're trying to add those together. Well, what do they add together to be? What do you call that? Do you call them fruits? What are we looking at here? So if you want to know the sum of something or the sum total something, we have to be dealing with the same thing or the same unit. And so the reason we need a common denominator is we need the equal parts of the whole to be split into the same size. So a visual of that, let's say we're adding 1/5 plus 2/5. So let me divide my little box. And I'll divide another little box. Okay, so 1/5 plus 2/5 would be, look at these little parts. There's 3 little parts total, and the whole was divided into 5. Oh, that's barely visible. Hold on. Let me see if is that showing up better? Okay, it is. This would be 3 over 5. Okay, but let's say you were asked to add 1/5 plus 2/3. So using our same representation, and then if we're talking about 2/3, it's hard to combine our size pieces here. Okay, so that's why they have to have a common denominator, because then we're looking at the same size pieces or the same size parts that we're adding up together. So let's practice this. So adding fractions. So our instructions are to add and simplify. So the first thing is to get a common denominator, and with that we can make an equivalent fraction that has the same, where they have the same denominators, so then we can add up or subtract the numerators to get our final answer. So in this case, we look at our denominators, 5 and 10. 5 can be made into 10 using multiplication. So if we need to multiply 5 by 2, I'm going to leave this one alone because it already has the common denominator. Multiplying 5 by 2, you also have to do the same thing to the numerator to make it an equivalent fraction. Remember, you're not allowed to completely change the problem. We're just making 4/5 more friendly so that we can add it to -7/10. So this is 8 over 10. Okay, and then 8 plus -7 is 1 over 10 is our final answer. And we'll do the same thing in part B. If it's not clear right away what the least common denominator is, there's two options. You could get a common denominator. It might not be the least common denominator by multiplying 7 times 9. Or what you could do is, a trick that I use is I start with the higher number. So in this case, it would be 9, 18, and then we have 27, and then we have 36. And as you're doing this, you're checking to see if 7 goes into any of these numbers, and 63 will do it. So in this case, 7 times 9 was our least common denominator. So to make our equivalent fractions, we multiply 7 by 9 and -2 by 9. And we're also going to multiply, since we need to multiply 9 times 7, we're also going to multiply 5 times 7. So what we get is -18 over 63 plus, and this becomes 35 over 63. Okay? And to get our final answer here, we would be doing -18 plus 35 over 63. So this is going to give us 17 over 63 as a final answer. Oops, 17. Okay. Next, subtracting fractions. So it's the same idea where you need a common denominator, but here you have to be a little bit more careful because there's more negative signs. Okay, so again, looking at part A, our common denominator between 3 and 5 is 15. Okay, so we're looking to get, using multiplication, 3 to 15 and 5 to 15. To get 3 to 15, we have to multiply by 5, which means we'll also multiply the numerator by 5. And then for 5, we need to multiply by 3, so we'll also multiply that numerator by 3. So we have 10 over 15 minus 12 over 15. So we have 10 minus 12 over 15, which gives us -2 over 15. And we know that's our simplest answer, or it's simplified because there's no common factors between 2 and 15. Okay. For the next one, 2 and 7 are the denominators we're looking at. Our least common denominator here is 14. So in order to get 2 to 14, we have to multiply by 7. And in order to get 7 to 14, we have to multiply by 2. Okay, so I want to take a minute to talk about this negative sign. When you have a negative in front of a fraction, it can go with the entire numerator, the entire denominator, or it can stay in front, meaning the entire numerator is negative. So you can rewrite this as negative 5 times 7 is 35 over 14. So you can see that negative sign with the 35, okay? So then we have minus, this would be 12 over 14. Okay, so this is reading as -35 minus 12 over 14. I might have just said 13. I don't think I did, but that should be 12 over 14. Okay, and then so if we subtract -35 minus 12, the way that I think of that is if you're $35 in debt and somebody demands $12 from you, you are going to go more in debt to be -47 over 14. So we've got multiplying and dividing left to talk about. I'll show the calculator screen and then I'll talk about an example problem. So multiplying and dividing. So when you're multiplying fractions, you multiply the numerators together and put it over the product or the multiplication of the denominators. With dividing fractions, you keep the first one, you change the division sign to multiplication, and then you change positions or you flip the second fraction. So here's what that looks like. When you're multiplying and simplifying, we go straight across. So this becomes 2 times 1 over 3 times 7, which is 2 over 21. Okay, and again, it's simplified because 2 and 21 don't have any common factors. With part B, there's a couple different ways you can go. So remember I said any whole number can be put over 1. So when you're multiplying fractions, if you like for everything to be a fraction, all you have to do is put that -4 over 1. And now we're talking about -4 over 1 times 7 over 4. So this would give us -28 over 4. And -28 divided by 4 is -7. And the other thing that you can think of with this problem is right here, this is multiplication by 4 and this is division by 4. So multiplying by 4 and dividing by 4 gives us 1. So that's another way you could do it, is to cancel. Maybe you've heard those out. With division, we keep the first one, change the sign to multiplication, and then interchange positions numerator and denominator of that second fraction. So we'll have 1/5 times 8/7. Okay, so here we go straight across, or you can simplify beforehand, that's okay. Okay, and then we need to get it in simplest form. These are both even, so this is going to give me 4/7. Okay, and then for this next one, 12/7 divided by 6. Again, personally, if I'm working with fractions, I tend to like to see everything as a fraction. So I would start by putting the 6/1. So now when I go to divide, 12/7 times, this is 1/6. Okay, and here I actually will cancel. So 6 goes into 12, so this becomes a 1. 6 goes into 12 2 times. Okay, so that becomes a 2. So now we're multiplying 2 times 1 over 7 times 1, which is just 2/7. Okay. So some calculator buttons here. I recommend taking a picture of this. You don't necessarily have to copy this in your notes. These are just some buttons in what order. So your calculator can simplify a fraction. It can change an improper fraction to a mixed number if you're interested in that, a mixed number to an improper fraction. Or what you can do as well is just put these fractions in and then hit equal sign. We may or may not be working with improper fraction or mixed numbers, so I wanted to make sure I put that up on the screen for you. But what I would do is I would go through these problems and make sure that you're getting the same answer. That top one, simplifying a fraction, might be the most helpful one. Okay, the other thing too is when you're dealing with fractions, remember that we talked about at the beginning that the fraction bar means division. So for some of your calculators, you might have to use the division symbol if there's not a fraction button. Okay, so I wanted to go through an example, kind of a more practical example of fractions. So if the President of the United States vetoes a bill, at least 2/3 of members voting in the House of Representatives and at least 2/3 of members voting in the Senate must vote to override the veto for it to become a law anyway. If all 430 members of the House vote and all 100 members of the Senate vote, how many votes are required in the House and the Senate to override a veto? So you may want to read it again. I always encourage reading word problems a couple times. But really what we're trying to find is 2/3 of 435 for the number of members that need to vote in the House and 2/3 of 100. So the first way I'm going to do this is I'm going to show you a visual. So 2/3 of 435. So what this means is that we can cut 435 into 3 equal parts. That's what this denominator is talking about, okay? So pretend this is my 435 members. If we cut this into 3 equal parts, each part contains 145 members. So basically it's like taking 435 people and splitting them into 3 equal groups. 2/3 of those have to vote in order for the bill to become a law anyway. So we would be taking 2 of those. 1, 2. Okay, so you add up 145 plus 145, which will give us 290. So 290 votes in the House are required, and we can try to do something similar for the Senate. If we do 2/3 of 100, if you cut 100 into 3 equal parts, you're going to get a decimal, which we'll talk more about in the next lesson. But it would be 33.3 repeating. Okay, and if you were to talk about 2 of those, you would come up with 66.6 repeating. Okay, another way that you could do this, so that would be 67, because it has to be at least 2/3, so it can't be below that, it has to be over that. You can also plug this into your calculator or do it by hand to where, let me go down at the bottom, this would be 2/3 times 435, and you would get the same answer, or 2/3 times 100, and you would get the same answer. Okay. Thank you for watching. If you have any questions, please feel free to reach out to me. I'm also happy to help you with your calculator. You would need to use a handheld scientific calculator for these types of problems on any sort of assessment, so make sure that you know how to use your calculator effectively.